All right, so there were two types of circuits, Jules. Two types of circuit, parallel and series. So in series, remember that the objects are always, the voltage varies. Voltage varies. The current is the same. And the resistance, it adds up like this. R1 plus R2 plus R3. All right, you just add them up. So let me just draw one real quick and let's go through how to solve it. So we've got like a 10 volt battery here. We've got a 3 ohm resistor here. A 2 ohm resistor here. And let's say we have an unknown ohm resistor here. This one's going to use 3 volts. This one's going to use an unknown volts. And this one's going to use an unknown volts. All right, so the series circuit, I want to know the current total in this system. How might I find the current total in this system? What can I use? There's an important piece of information. First of all, remember, how does the current compare? It's the same. Juan, do you have an idea? What do I do? I thought I saw your hand. Nope. Okay. So what do I, this is the important part. What can I do with this to find? I can use V equals IR. So V equals IR. So 3 equals I times 3. What would be I? 1. So 1 amp, which means that this one would have how many volts? 2 volts. All right, if this thing is 10 volts, and this one has 3 volts, and this one has 2 volts, how many volts does this one have to use? 5 volts. Which means that the ohms of this would have to be 5. All right, so we filled in all the blanks. Next we had parallel. So we did parallel. And in parallel, the voltage was the same. The current was different. And the resistance added up funky. Was 1 over R1 plus 1 over R2. And remember, you had to add that up and then invert it. Y'all remember that? Good. Okay, let me try one more problem. And then we will call it a day. Okay, so what if you have a circuit that's got both parallel and series within it? So I'm going to put 2 up here. Here's one simple one, or simple-ish one. Okay, this one was on your on one of your assignments. So it had everybody had the same thing. And so how would you go about thinking about this one? So we've got everybody has the same thing, right? But see how this guy, what's this guy in with these 2? How does this one in with these 2? What kind of circuit is he in with them? He's in series with them, right? But these guys are in parallel, right? But this isn't in parallel, is it? No. So what if we wanted to figure out the resistance total of this system? Would we just do 3 plus 3 plus 3 plus 3? No.
I think it could. It would be the same.
Would it? No.
Yeah. You do 1 over 3 plus 1 over 3 plus 1 over 3. Which
Right.
It will be 9.
But wait. What do we need to do with this? Should we add, we add this up first.
Oh.
So we would get 6 ohms. Then we add up this, which would be 1 over 3 plus 1 over 6, which would be 1/2. And the resistance down this path would be 2 ohms. And then it's in series, so 3 ohms plus 2 ohms would give us a total resistance of 5 ohms. So when if you get one of these, you start at the smallest point. So this is a series circuit. It's got a parallel within it and a series within the parallel. So you start with the smallest and then you work your way out. Does that make sense? So the total resistance here would be 5 ohms. One of the questions that I asked you in the book, or in that problem set I gave you, was which one would be brightest. I suppose the way you can figure out how to do which one's brightest is by figuring out which one uses the most power. One that uses the most power will be the brightest. So if we were trying to figure out which one was the brightest, we would need to figure out which one had the most power flowing through it. So you should know that the current is going to be the same here, except this one's going to get, like, let's just say the current is 3. If the current's 3, this one's going to get 3, but are these two paths going to get 3? No. So they're going to split that current up. And so since they're going to split that current up, they're going to be less bright because they don't get as much current, so they can't generate quite as much power. Does that make sense? We also know that this one's going to eat up some of the voltage. So he's going to eat up some of the voltage before he sends it on, and so they won't have quite as much voltage either. Does that make sense? Okay. So there we go. That's a series in a parallel circuit. We've talked about waves, we've talked about energy, and we've talked about momentum. Anybody got any other topics they want to talk about?